So, good evening, everyone. Is my voice audible? Thank you. So, welcome to the TRL FutureX on data cleaning with Pandas. So, let me just present my screen on PPT. Okay. So, is it visible? Okay. Thank you. So, today's topic is about data cleaning Pandas. So, why do we need data cleaning? As we all know, this is an era where it is all taken over by AI. So AI, so it needs data. So there might be many sources where this data comes from. So we need to get a proper formatted data. So the various sources from where we get data might contain some items that might not be suitable for training the data, for training the LLMs. So over in this session, we would be learning how to clean those data, a proper format in a very beginner level. So what is Pandas? It is basically a Python library where it contains a data in form of rows and table, just like spreadsheet. So the next question arises: why? So what is the need of new Pandas when we already have spreadsheet? So spreadsheet, or you can say Excel, contain the data and where we manipulate the data manually. But this pandas thing is totally based on scripted, where you can change, where you can automate the things as it is a Python library. So we use pandas for that case. So we can automate it. We can use it by using the code level. So over here, we would be reading the files. So we need some source where the data will come from. So from that, we can have CSV data, Excel data, or in a JSON format. It helps us to explore fast, to summarize the data. Over there, we can filter out some data, or we can sort those data. We can group it and help and put many functions over there, many calculations we can do. Going to the next one. So there is a main important thing. What is data frame and what is series? So basically data frame is just a table. The table we can see is the data frame. And so what is the series part? So series is just a column from that table. So over here you can see a name column, department column, and salary column. So these are the series which whole comprisely known as data frame, the whole table, we can say. It's a 2D matrix. So for this session, we would be using this CSV file, employees CSV file, for testing out different functions available in Pandas. So we move to loading the data. So for this, we would be needing a Google Colab and a data set, which is employees.csv. So let me just show you that. So this is our data set, which is employees.csv. So here we are having 6 columns: name of the employees, different departments we are having, and different ages, salaries, city, and their year of experience. So this would be the data we would be working on. So let me show you the PPT again so that we would be starting with. Okay. So first we will install or import Pandas library of a Python. So Pandas is the one which we will be using for different modifying the data, different calculations we will be doing. Then we would be reading that CSV file. By reading, we would be loading that data file, that CSV file, and then we would be working on different functions over there. So let me show you that Google Colab. So is it visible? Okay. So for starting, this is the Google Colab. It is just you need to search Google Colab, and by clicking on the first link, you would be directed to that first by creating a first notebook. So you click on that for creating first notebook, then you open it, and this would be your screen for that. And now we need to upload that CSV file, which we had, employees.csv. So over here, first I need to, this is the file section. So you need to click on that. And over here, there is an upload button. So you need to upload that CSV file. Okay. So our CSV data has been uploaded. So our first task is to import that file, import that library. So we have imported, I have written import pandas as PD. So what is PD? So we are over here aliasing the library so that it would be easy for us to work on. So we don't have to write a long library name. So over here I execute it. So it has executed. So now we have to read the data, that employees.csv file. So over here, I have writing pd.csv. And over here, I would be mentioning that file, CSV file. So I'm executing it. So it has been executed. Now let's check what is there in that DS. So DS is nothing, just a data frame, the whole table of it. So let's move to the new function, which is ds.head. So this function, what it does basically, it returns the first 5 rows. So by head, you mean the top 5 rows. Top 5 rows means the first row, second row, third row, and fourth row. So let's check and execute it. So here it is. So you can see the first 5 rows have been executed, have been shown. So let's move to the PPT. So now we would be exploring the data. So the first function is ds.save. So save returns the number of rows and columns of that CSV file or Excel file. So then the next function is ds.column. So it basically returns the column names of that table. Then comes ds.datatypes. So data types of that particular column, it would return the data type of those particular columns present in that table. ds.info. So it is basically the structural overview of that table. So what is the data type of that? Any missing values are there or not? And then there is ds.describe. So it is the statistical overview. So over here, we would be seeing the mean value, the median value, and other percentile values. Then comes df.tail3. So the way we have the first 5 rows from the head function, so by using tail, we can have the last 3 rows of that table. If you don't put this parameter 3, so it would be by default returning the last 5 rows. So let's work on that in the Google Colab. So the first function was df.fill. So it is showing 15,6. So what is that? So it means 15 rows and 6 columns. Let's verify that. So we have 15 columns, 15 rows of 15 employees and 6 columns of name, department, age, salary, city, years of experience. So let's move to the new function. The next function is df.columns. Sorry. So this returns the name of the columns we have in that table: name, department, age, salary, city, years of experience. So move to the next function. So the next function is df.dtypes, which shows the data types of that function. So this shows data types of the columns present in that table. So name showing object, department object, age int with a 64-bit, salary with int 64-bit, city object, years of experience int 64-bit. So you might be thinking, so why the name, department, and city have object type? Because it is just a string. So the thing is that in this pandas, it considers the string or text type data as an object. So let's move to the next function, df.info. So this shows the structural overview of the table. So these are the columns, how many non-null values, means how many non-missing values, and what are the data types of those columns. Now move to the next function, df.describe. So df.describe is the statistical overview of the table. So count, it shows the number of values having non-null values. Mean is the average of those age column and salary column and years of experience. So you might be thinking why there is not name column or city column, because those are non-numeric values. So this kind of statistical value is only applied to those which are numeric in nature. STD, which stands for standard deviation, minimum value, the minimum age of that table, minimum salary, and minimum years of experience. So 25 is the 25 percentile, 15 percentile of the data, 75 percentile of data, max value of those tables or those columns. So you might be guessing what is the 25% percentile or 50% percentile or 75% percentile. So let me show you the calculation of that. So as we are having 15 rows, so there are functions and the formula is n-1 into p. So n, we are having 15, and p, which is the percentage value, 25%. So we would be writing 0.25. So 15 minus 1 into 0.25, so it would be 3.5. So the next value is the low value. So we are having 3.5. For finding the statistical value, we have to first sort them in ascending order so that we get those values. So you can see over here, we have the sorted values. So 3.5 means that it is between third and fourth row of the salary. So this is the low value, this is the high value. Third row is the low value, fourth row is the high value. So first, the formula is low plus the decimal part of this position into high minus low. So the low part is 54,000, which is over here, plus the decimal part of 3.5, which is 0.5 into 54,000 minus 58,000. Sorry, 58,000 minus 54,000, which gives 56,000 value. So let's check whether we have got that or not. So yeah, 25% of salary is 56,000. So this is how we would be calculating our 25 percentile, 50 percentile, and 75 percentile. So any doubt till how much we have covered? Any doubt in those functions? Okay, I hope we are okay with that. So let's move forward. So now we will be selecting the columns and rows. So for selecting or viewing the particular column, we would be writing df of bracket, df of salary. So as I have told you, the difference between data frame and series. So a series is where we only select one column, one value. And if you want to see several columns, so we would be using two double square brackets. So as we have used more than one column, so it's a data frame. So it's a whenever we use more than one column, so that becomes a data frame. Data frame can be a whole table also, or it can be a table containing more than one column. Then we are having df.loc, which shows the value of the 0th row over here. And df.ilocation, it also shows the 0th row, but over here we use the label or the name if we are using name column. So we can write over here name, and but in this iloc, we don't put the label or the name of the value. We put only integer values. Let's check that in Google Colab. So for checking out the series, we would be showcasing the salary column, df of salary. So let's run that. So you can see the salary of all those employees are visible. So let's move to the new function, df of salary. Sorry. Let's check for name and salary. So you can see it is showcasing all the salaries of all those employees. So this one, first out is that series one, and this is the data frame part. So now showcasing the rows value. So this would be giving us the 0th row values. So this is giving us the 0th value, 0th rows value. Let's move to the so this also gives the 0th row. So the difference I might show you. df. So if we want to see the first salary cell, so let's 0th is the row, then we would be checking out the 0th row's salary value. So this is the value we have in the 0th row's salary column. So let's verify that it's 72,000. So yes, you can see the first employee's value is have been shown 72,000. So how we will do that with iloc function? df dot iloc and 0, 0. So 0 over first 0 represents the row, and the second one represents the column. So if we want to see the salary column's value, so this is the first column, so it would be starting from 0. This is the second column, which would be 1. This is the third column, which would be 2. And this is the fourth column, which would be the having value 3. So we would be showcasing 0, 3. The same value we can see over here. So let's move forward with our PPT. So now we would be filtering rows by condition. So let's move forward. Dear. So the first one is like we would be working, we would be finding or filtering out the employees earning over 70,000. So how to do that? So we would be writing DF, which is the data frame, so realizing the whole data frame, the whole table. So it starts like DF with a square bracket with unnested DF of salary whose value is greater than 70,000. So how we would work out. So this one, so the first thing that gets computed, it would compute from the whole table the salaries which are greater than 70,000. So those salaries which are greater than 70,000, so it would be maintaining all the rows as true or false value. The rows which are maintaining this condition will be true, and those who are not, which will be false. So it arrives at this position. So now it would be showcasing all the values, all the rows which have true data. Then comes only the what we need to see right now is the only team where it is engineering. All the departments where it is, all the employees department where it is all engineering. So same way, it would first compute this part. So it would be checking all the department with engineering value. So if it's true, then all the rows would be true. And if anything is other than engineering, would be marked as false. So it would be returning all the rows which have true value. Second, when we have multiple conditions, so we would be maintaining it using a round bracket so that we can maintain the precedency of those functions. So the first condition is the age, which is less than 35. And we want to check all those employees which have salary greater than 60,000 and age less than 35. So we would be using over here AND function. So first thing, it computes the age which are less than 35 and the salary which are greater than 60,000. So it would be returning all those true values. So let's check that on the Google Colab. So first thing we would be checking the salary which are greater than 70,000. So it has shown us the employees which have having salary greater than 70,000. So you can see 72,000, 81,000, 72, 89, 78, 95, 87, all greater than 70,000. So let's move to the multiple conditions we have. Let's start that in parentheses. Let's run that. Okay, so we have got all the employees having age less than 35 and salary greater than 60,000. So you can see that all the ages are less than 35 and all the salaries are greater than 60,000. So do we have any doubt regarding all the things we have learned right now? Okay, So let's move forward. So the next topic is sorting and summarizing the values. So over there, the first function is the sort underscore values. So where here we would be sorting out the salary value with ascending equal to false, which means it is a descending order. So the function is df dot sort underscore values, which says salary. The first parameter would be salary, which is showcasing the column on which you want to sort, and the second is ascending equal to false, means you want to check for descending order. If you want to check for ascending order, you don't have to put this second parameter. So next function is now counting the rows per category. So we want to find the number of employees per department. So what is the number of employees in engineering and other departments? Average salary per department. So in this function, what we are doing is that we are finding the average salary of each department. So let's try that in Google Colab. So the first one is sorting those values. So we would be sorting out the salary one with the value in descending order. Okay, let's check out that it worked or not. So all the salaries in descending order. Yeah, we can see it is in descending order, where the largest one is 95,000, then it comes 89, 87, all in decreasing order. Great. So let's move to the next function. So the next function is the counting the rows per category. So we would be counting the employees having how many employees per department we are having. So here is the data. So engineering contains 4 employees, marketing contains 3 employees. That's how it is all about. So let's move to the next function, which is getting the average salary of per department. So we would be using groupby function to group the department column, and the average we would be finding on salary. So salary, and we would be using the mean function to get the average of the values. So see, so engineering department have a average salary of 81,000 and finance 77,000, and that goes. So let's move to the next topic. How to add a column and save it, or to get a new CSV file. So creating a new column, what it means. So we are having over here 6 columns. What we want is like what extra data we can put or some extra fields we can use. So the extra field like bonus, what we want over here is we would be adding the bonus column also. So it is just you have to mention the name of the column, new column, equal to, if you want to create any normal static values, you can put 1, 2, 3, or if you want to get it calculated from the existing column, so you would be using equal to df of salary into any values if you are counting for bonus part. And if you want to check that, if you want to put that new thing into the another table, so you would be writing df to csv and that would be an updated one so that you get a new CSV file. Or if you want to get it done in that same file, so you would be writing the same file's name. And indexing false means you won't be showcasing the index value or the main primary column where it would be maintaining the index of the or the rows label. So let's try that out in Google Colab. So creating the new column, which would be the bonus. So let's run that. So it is there. So we could be putting it into a new file, employees updated. Don't forget to mention the .csv file, and indexing would be false. So let's run that. So it would be visible over here. Yeah, over here it is. So let's check that out, that whether it worked or not. So over here, we would be creating another variable to store the data of this new column. So pd dot, which would be the pandas, and read CSV file, read CSV function. So we would be reading this new CSV file, which would be employees. So let's run that. So it is there. So now we would be checking the data frame. Yeah. Over here, we have this new column with the bonus value of each employee. So that is all the topics we have covered. And let's get the overview of what we covered. So the 15 commands which we learned today are import pandas, where we would be loading that library, and df.describe is the statistical value, which would be the statistical value of the whole table. Then we have pad.read CSV, which would be reading the CSV from the for the data frame part. Then we have filtering the rows, where we would be conditioning, putting the condition to filter out the different rows or different column values. Then we have df.column and df.datatype, which would be maintaining the names of the columns and the data types of the columns. Then we have df.sort values, where we would be sorting out the columns. Then we have df.head, df.tail, which would be for the figuring out the first 5 rows or last 5 rows, respectively. Then we would be showcasing the column. If you want to show a particular column, we would be writing df.column, the name of the column. And if we want to count the values per category, so we would be using value counts function. Then we would be using save function, that is for the rows and number of rows and columns. If we want to print several columns, we would be using multiple column names with double brackets, double square bracket, so that it would be returning us the data frame part. Then we could be grouping it to get the summarized value. For this, we can use mean or any other statistical functions. The info part is the structural overview of the database, or sorry, the data frame. And then we have df.log and df.iloc to get the rows by label, by the name of the column name, or by the position, which are the integer values. Then if we want to return or create a new CSV file, we would be using two CSV files. So this is what. Thank you. So now, do we have any questions? Any questions regarding this topic? Thank you. Stay tuned for the new topics which I would be arriving in the future. Thank you.